Okay, let's take a look here. Yesterday you learned scientific notation. Let's just write down the rules. If the number is greater than 1, then it's going to be a positive exponent. Write that down. If the number is less than 1, then it's going to be a negative exponent. So let's take a look here. Well, this number here is obviously less than 1, so it's going to be times 10 to a negative power. That's the first thing you do. Now you want one number in front of the decimal, so you got to move this thing 5 places, so it's going to be 4.0 times 10 to the negative 5, and that's your answer. Let's take a look at the next one. 71 times 10 to the third, well, that looks like scientific notation, but you need one number in front of the decimal. So look here, 71 is bigger than 1, so that's going to be a positive exponent, okay? And you get that little mark out of there. So it's going to be a positive, and we need to move it one place. So it's going to be 7.1 times 10 to the 4th power, because you moved it one place and it was bigger than 1. Okay, just use your rules. Look at this one. Same thing here. You're going to move it. It's bigger than 1, so it's going to be a plus. You're going to move it one place, so it's plus 1, so it's 3.3 times 10 to the negative 2 when you add these up. Okay, write in standard form. If it's a negative, you have to go in the negative direction one place. So the decimal's here, so it becomes 0.2. Watch again. Any number to the 0 power is 1. 4 times 1 is 4. That's easy. This one right here you can divide. 6 divided by 3 is 2. Here you can subtract your exponent. So bring this 2 up. That becomes a negative 2. So it becomes times 10 to the negative 6. And you're done. Today you have a worksheet. So if you can't be with us, it's right here. And I will upload it to Canvas and also put it where you can find it on the chat for those of you at home. Okay? And here it all is right here. Okay? That's you. All right, let's go to geometry. All right, let's finish up these relationships here. Well, what is a median? Well, let me use a different color. A median is a midpoint. So write that down, midpoint. So you want to go in the middle, in the middle, in the middle, and then you want to connect it to the vertices. These points are called your vertices or vertex. And where they meet, and I'm going to look at the board, that point right there for the median is called a centroid. So put centroid. In the centroid, the property is it's 1/3, the short piece, and the bigger piece is 2/3. Write that down. Those are your properties for the centroid. Also, it's called the balancing point. So if you put your finger underneath the triangle, it will balance like you do with a basketball. Altitude, you have to turn 3 times. Write this down. Turn 3 times. So I'm going to look here. This is the ground, and I'm going to come straight down. That's 1. Then I'm going to turn it like this, where this is the ground, and I'm going to come straight down. So on this one, an obtuse triangle, this point is on the outside. So that altitude gives you something called the orthocenter. Okay? And that's all you have for that one. That is your orthocenter. The angle bisector, you split these angles, split it, and then connect it. Okay, so you're going to come through here, and come through here. This point right here for the angle bisector is going to be the incenter. Okay, again, write this down because these are your notes. So that is the incenter. Okay, now, what is the significance of that? Well, you can put a circle, you can put perpendiculars here, and I'll use a different color. Perpendiculars here, and the perpendiculars here. Those are the radiuses for the circle that can be inscribed. Okay, so write this down. Distance to sides of triangle are equal, are congruent, and it's your radius. Write that down. That's called your incenter. And then the perpendicular bisector, okay, and I didn't draw a triangle there, but I'm going to do it here. So here's a triangle. A perpendicular bisector means you got to go 90 degrees and halfway. 90 degrees and halfway. This point right here for the perpendicular bisector is called the circumcenter. Now, what is the significance of that? Well, the distance to the vertices, or vertex, you had one like this on your worksheet. Those distances are the radiuses, and they're all equal. And it is the radius of the circle that can be put around here or circumscribed. And notice the circle has to hit the vertices or vertexes. Plural is vertices. Okay, so this one, the distance to the sides are the same. This one, the distance to the vertices. So if this was a business and you had one like this on your paper, let's say this is the clubhouse. This one right here is the newsroom. And this one right here is the rec room. If you're going to put a water fountain to be the same distance for everybody, you'd put it right here on your circumcenter. All right, that's what we learned. Those are all the properties, and that's all the stuff you need to know. Now let's move on to today's work. So put 5.4 on a neat sheet of paper and copy all of that down. All right, let's take a look at some of these rules here. Rule number 1, the bigger the side, the bigger the opposite angle. So draw this triangle and make this one 5, 4, and 8, and then label it A, B, C. All right, it says the bigger the side. Well, this is the bigger side, and the opposite angle is bigger. So this angle right here, angle B, is biggest. So angle B is the biggest. That's the big one. All right, 5 is in the middle. All right, so angle C would be next. And then the smallest one would be across from the angle opposite 4, side 4. So angle A is the smallest. This is the medium. So on the ELC, they might ask you which side is the biggest or which angle is the biggest. Well, you go to the biggest side. They might ask you which angle is the smallest. Well, you go to the smallest side, but you got to go across. So take your pencil and draw an arrow across. It says opposite. The converse is true, okay? So the bigger the angle, remember you got to switch. So the bigger the angle, the bigger the side. Copy that down. So draw this triangle. Let's make this a 30, 60, 90 triangle. Now, I know this is not a 90-degree angle, but so what? Copy that down. Okay, according to this, the bigger the angle, so 90 is the biggest. These are smaller. And across from that would be the biggest side. So the biggest side here is side AB is the biggest. The smallest side would be across from the 30, so BC would be the smallest. This is the biggest. Make sure you understand that concept. So the converse is true. All right, now let's take a look here. Let's say they don't tell you what this side is. Well, you know every triangle or this angle. You know that every triangle is 180. So this is 50, so this has to be 130. Now the diagram's not right. So the bigger side would be across from that. So this is your biggest. Across from the 20 would be your smallest. And the 30, this side right here, would be in the middle. All right, watch again. 5 is the biggest side, so go across. This is the big one, angle B. This is your small one, and this one is in the middle. All right, real simple. Copy down rule number 3. The sum of two triangles, or two sides rather, of a triangle must be bigger than the third side. Memorize that. So look here. If I add up these two sides, I get something bigger than 20. Okay? Watch. If I say, and I want to see the work, so 18 plus 19 has to be bigger than 20. And I think it is. So 18 plus 19 is certainly bigger. So this is true. Let's try these two. 19 plus 20 has to be bigger than 18. And it is. And then finally, let's try these two. 18 plus 20 has to be bigger than 19. You have three possibilities. Copy this down. This is true for all of these, so this makes a triangle. So this would be yes, it would make a triangle. Okay? Let's try this one. If I add up these two, it is bigger than 40. That's true. If I add up these two, 19 plus 40, it is bigger than 18. That's true. And then if I add up the first and last, it is bigger than 19. So this one is a triangle too. Now, keep in mind that if it doesn't work out, if it fails any of these, then it does not make a triangle. All right, let's keep moving. Now, to get the range of the third side, you would add these up and subtract. So add and subtract. Copy that down. So when I add these up, 11 plus 16, I get 27. So 27 is a possibility. And when I subtract these, 16 minus 11, I get 5. So the range can be from 5 all the way up to 27. Now it can't be 5 and it can't be 27, but it could be 6. 6 would work. 26 would work. Anything in between these numbers. So you add them and subtract them. Make sure you know that. These are all triangle inequality rules, and you need to know them. Here's your work for today. Make sure you show all work, and if you need to, copy the diagrams. And I want to see the work, like I did here, where I added them up and subtracted them. All right, anyhow, have a good morning, and I'll help you in class. This is out of the workbook. Page 230, 1 to 33. Have a good morning.